So first thing we'll do before we dive in is just take our quick look at the calendar. Today is class number 4. We're going to cover section 3.1. Davis had asked the other day, is it true? Are we really jumping around? Yes, we're really jumping around, but hopefully the material itself will kind of be fluid and smooth as we go through. Today we tackle ratio and proportions. A ratio is just a fraction. A proportion is two fractions equal to each other. Nothing more, nothing less. Okay? Fraction or fraction equals fraction. That's what we're after today. Again, quest number 1 is coming up. It is 1 week from today. Make a note in your calendar if you haven't yet. This is our first significant, it's not a test, but it's bigger than a quiz. It'll be a full period thing, and it's coming 1 week from today. Okay? And the material that this quest is on is right there on the same line. It's classes 1 through 5, all right? So we're going to work on class number 4 today. The quest goes up through class number 5, which is Monday. We'll have a regular class Wednesday, but the stuff from Wednesday is not going to be on Friday's quest, okay? So we got today and one more day of new stuff. That's the end of the material for the quest. We'll talk more about the kind of format of the quest next week, but it is coming, and it is certainly not too early to start studying for that. All right, it's 1 week from today. Davis? No. Good question. Let's talk about that next week. Okay. All right, one other thing. I know that most of you have been doing your homework very regularly, and that is wonderful. I know also that sometimes life gets in the way and you can't do the homework even though you'd like to because you just don't have time, which is why I've got that 1 day grace period built in. That said, there is another grace period, which I have not talked about yet. It's in the syllabus, but it says something like, I will accept any missing homework from the first 5 classes, actually first 6 classes, on the day of the quest. I'll say it again. I will take any homework. So if you have not turned in a shred of homework yet this semester, start doing it. Don't give it to me Monday because I don't want to be inundated with like 5 different days of homework on Monday. But during the quest, I'm prepared to sit down while you guys are working hard on the quest. I'm going to be working hard grading all this old homework, all right? The goal for me is for you to do the homework. And even if you didn't do it on Wednesday or Monday like I wanted you to, I still want you to do it. So this is the last opportunity, that day right there, Friday, for you to make up the old homework from the first part of the course. Now it comes at a cost, and the cost is 10%. So if you do all of your homework perfect, if you haven't turned in any homework yet, and you turn it all in on that day of the quest, you'll get a 90% on the homework. Okay, it's not 100, but it's a lot better than the 0 that some of you have, all right? The way to avoid the penalty is to turn it in either the day it's due or the very next class after it's due, all right? Once we passed quest number 1, I'm not taking homework 1 through 6 anymore. The only late homework I'll accept after that will be the stuff that's in between here and here, okay? So it's really broken up. I'm taking late homework, but don't turn in May something that was due today. Right? We're only going to go up through the quest. So we'll be more clear about that as we get through. But in any event, I just want to say, even if you haven't done any homework yet, it's not too late. You can still earn up to 90% of those points. Start working on it. Be ready to turn it in next Friday. Any questions on that right now? Okay, so we begin here on page 17. Now, I was looking through these notes on page 17. Oh, just one thing. I have somebody who did the syllabus questions but did not put a name on it. So if you haven't gotten yours back, this is probably yours. So open the folders, make sure there's nothing in there. Is there anybody who hasn't gotten their answers returned to them from that question about the syllabus? These aren't yours, are they? Okay.
Yeah, that's mine. Oh yeah, that's my giant.
Okay. So I was looking through the notes recently, and there's a little bit that I'm going to take off and a little bit of the order that we're going to change. But let's see if we can start. We're going to dive in here on this part. So can we begin with Ben? Here's a ratio.
Here's a ratio from the world's samples derived Montreal lab. No evidence that anything was. There was something missing from the sample. So I refer you to the ratio of testosterone to
Epitestosterone.
ratio of excess of 4-1 triggers a positive.
Okay, so I think, and I don't know, I'm not the one that grabbed this article, but certainly cycling and doping has been in the news of late. And how do they decide when they're doing their drug tests whether or not somebody might be suspected of doing drugs? And so what they calculate is ratios. Like, let's suppose that I'm taking some kind of steroid and it's illegal and it's going to help me be a better teacher, right? Okay, so I'm taking this steroid and I have, let's say I have like 1 milligram of this drug in my body. Now suppose there were another person, and this other person was, let's say, 3 times my size. Okay, if they had the same 1 milligram in their body, well, that's not going to help them near as much as it's going to help me, right? So it's more a matter of thinking about how much drug do you have compared to how big you are. Okay, it's not exactly that, but this kind of idea of comparison is what ratios are about. So apparently the ratio of testosterone to epitestosterone is not supposed to be any more than 4-1, which means for every 1 part of epitestosterone you have in your body, you better not have any more than 4 parts testosterone. If you have more than 4 times as much, then you're probably doing some kind of drug. So anything bigger than a 4-1 triggers this positive test, and Braun apparently had something in excess of 20-1. And so that was a big old red flag. Hey, this is way beyond the normal ratio that we might expect. So let's come back up here to number 2. And can we go around? Can you read number 2? Oh, sorry, the other number 2, my fault. Go up. Quotient. Such as? Colon B, but we read it A to B. So A to B, 4-1. That's how we write ratios. It's just a fraction. Okay, let's go to the second number 2. Adam? Can you read the second number 2 for us? Nope. Okay, Glenn.
QCC often uses ratios to mitigate tax harm students. For example, in the fall of 2011, there were 2,500 students. These 2,500 students, 2006 failed. Find each of the following ratios.
Okay, so let's try this. Part A says we want to find the ratio of female students to male students. Female students to male students. You see, and I've already gotten the fraction partially written out here. The first thing you're supposed to take away from this is whatever word comes before the word to, in this case it's female, goes on the top of the fraction. Whatever word is first goes on top. You just have to know it. Maybe there's some silly way we can remember how to know that, but it's just a fact. First word, word before 2 goes upstairs. The word after 2 goes downstairs. Always happens that way. So female students to male students means female is in the numerator and male is in the denominator. So let's calculate. I'll start downstairs. How many male students were at GCC at this time? 1,006. That goes down in the bottom. Does the problem tell us how many female students there are? No, but we have the ability to figure that out, right? If there are a total of 2,501 and 1,006 were male, the rest of them were female. So let's go ahead and do that subtraction. Okay, what do we get here? 1395. Do that right?
I got
1495. Thank you. Okay, so 1495, that's the number of female students. Where does it go in the fraction? It goes on the top. It was first, so it goes on top. So this is 1495. So there you go. The ratio of female students to male students, 1,495 to 1,006. Now, if you have a calculator handy, let's just type this in. We're going to get a decimal, but the decimal gives us information. Okay, so we got 1495, and then we divide by 1,006. And even without the calculator, we're expecting something about 1.5, right? I mean, it's about 1,500 over 1,000, so should be able to get something, at least an estimate. Okay, 1.486. We'll call that about 1.49. So this is roughly 1.49. And just to really keep it as a fraction, because ratios are always written as fractions, what number is down there even though I didn't write it? It's 1, right? The only number you don't have to write if it's in the basement is a 1, because dividing something by 1 doesn't do anything. So usually we don't write it. And in fact, most of the time, if I see that written on a quiz or a test, I'll say this person doesn't understand that dividing by 1 does nothing. But in this case, I want to put it. I really want to stress that there's a denominator there, and I think it's useful to put the units. Upstairs still represents what kind of student? Still female. So this is 1.49 females, and downstairs is males. So in English, that 1.49 means for every 1.49 female students at GCC, there is 1 male student. Which one has more? Females. About 1.5 times as many. And to be honest, that ratio, this 1.49 to 1, is probably a lot easier to understand what does that really mean about the GCC population than to say there are 1,006 male students out of 2,500 total. It's really about comparing, because I could do the same kind of comparison at UMass, which has many more students than we have here, and still get to something like 1.49, which I can understand, as opposed to thinking about thousands or tens of thousands of students at some of these bigger schools. Ratio is a way to really make it so that it's easy to look at that number and understand what's really going on with the makeup of the student body. Okay, go ahead and try part B. Ratio of female to the total number of students. Fill in the blanks and then use your calculator. So make sure 1495 is upstairs. What's the decimal here? Okay, so something around 0.6 if we round it. 0.6 divided by 1. You can always put a 1 down there. That's what's there if you're typing it onto the calculator. And that is 0.6 what? Females divided by 1 what? 1 any student, total student. For every 0.6 female students here, there is 1 total student. You could think of that one maybe as a percentage, actually. 0.6 is 60%. So 60% of all the students are the female students. And that's also easier to understand than 2,500 and 1,000. 60% of the student body here is female. So I think it's nice to be able to work with the different ways of saying the same thing. Oftentimes, some of them are easier to really understand than others. Okay, moving down, we'll continue with number 3. We'll go around to, let's see, we're finished there. So we'll go to SevTap here, 3. Mm-hmm. Okay, so we've actually written a couple of unit ratios up above. We just need to have different units and a denominator of 1. So for example, right up here, 1.49 over 1. That's a unit rate or a unit ratio. And the same kind of thing with this 0.6 over 1. And the reason unit ratios are good is because you can say things like, for every 1.49 females, there is 1 male. Okay, let's go down to the next part. I'll go to Dan. Okay, let's pause right there. You guys are comfortable seeing these kinds of things up on the gas station sign, right? It'll say 3.93. Why is there a 9 at the end of that number? Yeah, I don't know if you're aware, but they're like, if you look closely at one of these gas station price signs, there's a little tiny 9. It looks like an exponent, actually. It's like small and it's up. And it'll look like 3.93 and then just this little 9 up here. And that 9 is 9/10 of a penny. And really there's, what's that? Sometimes they do have a little 10 up there as well. And that's 9/10 of a penny. And I can't think of any other place where fractions of pennies enter into my daily life. But here's a place where they do. And why do they do that?
Feel better about not spending that extra penny.
Yeah, I mean,
Not making hard.
right. I mean, it's gas is not 3.93. It's much closer to 3.94 than it is to 3.93. I don't know why they do it. It's some psychological marketing mumbo jumbo. But the fact is, you are paying basically a penny more for gas than it looks like. I mean, nobody really inspects that little 9/10 over there. I don't get it, but that is a unit ratio, and we could say the same kind of thing. Suppose that you went to the gas station, and instead of saying this, it said this: gas costs, let's say, $8.47 for every 2.36 gallons. That would be a lot less useful to me, right? It could be completely the same price for gas, but it's really not useful for me to know at this gas station how much 2 gallons and change costs, whereas the gas station right next door has a different thing down in the bottom. They're telling me what it costs for 5.3 gallons of gasoline. So having it be a 1 in the denominator allows us to compare. It becomes apples to apples. This is why we like having the 1s down there. All right, next page. And we'll go up there to number 4. Can we go to Teresa? Okay, so I'm going to highlight one word here that tells you where the fraction, how the fraction is supposed to be written. It's the word 2. You're going to see it in every ratio problem. So you're going to write a fraction. This word 2 tells you exactly where you're supposed to go. So see if you can figure out what the fraction is without the calculator. Write it down. And then when you're ready, you're typing it into the calculator. Okay, any questions on why the 4-year number goes upstairs? Yeah, because that came first. Any questions on getting the 2.93? We'll just type in the division. Okay, and now we're going to write it so that it really looks like a ratio. What number goes downstairs? 1. And I think having the units written in here helps. That's $2.93 and $1. What does it mean? It means for every $2.93 that it costs to go to what kind of a school? A 4-year school, it will cost you $1 to go to a 2-year school. It's giving you a sense of how much more expensive it is to go to a 4-year school. It's about 3 times as expensive. For every dollar you might spend here, you go to UMass and perhaps it's $2.93 there. I think it's much easier to think about those numbers than $66.95 and $22.85, at least for me. It's something that I have a better feel for. Okay, moving on. What we're going to do is jump down for just a moment to this number 6, and then we'll come back up to 5. So 6, I think we're over to Evan.
There are many situations in which proportions describe ratios that are, for example, it takes approximately 40 gallons of sap to make 1 gallon of syrup. So if we have 4,000 gallons of sap, it will take approximately 4 gallons of syrup. That's a proportion we write as.
Okay, so let's just take a look at this fraction and some facts about syrup and sap. Okay, so it says 40 gallons of sap, which is a whole lot of stuff, will get you 1 gallon of maple syrup. If you ever go out and buy maple syrup, what do you notice if it's the first time you're buying it? It's really expensive. I mean, like for a gallon of maple syrup, you might be looking at like $60, $80, right? I mean, it is expensive. Why is it so expensive? Because it takes so much of this other raw good, the sap, to make 1 gallon of syrup. So the sap, I don't know if in the like throughout the year, sometimes you see these trees that have buckets hanging from them. Anybody seen these before? Yeah, so like some people will just go and they'll put like a little tube into the tree and the tree will slowly drip out the sap. It takes 40 gallons of that stuff to make 1 gallon of maple syrup. That's why it's so expensive. If you find syrup that is inexpensive, then it is not maple syrup. It is a bottle of corn syrup, which is really cheap. And then they throw some artificial flavors and other sugar on top of the sugar. So it might taste kind of good, but it is not this stuff, and that's why it's so much cheaper. So here is the first part of the ratio. It takes 40 gallons of sap to make 1 gallon of maple syrup. It doesn't really matter what order you put them, but it does matter that you're consistent. If we have gallons of sap upstairs here, we better have the same exact unit upstairs over there. So just be consistent going straight across. So 40 gallons to 1 gallon, 4,000 gallons to 100 gallons. And we're going to solve some equations that look like that in just a few minutes. So let's come back up. Evan read us this word proportion. We're going to define it right here in number 5. Michelle? A over B equals C over D. The word proportion just means fraction equals fraction. That's it. So let's come down here. We're going to extend this idea of proportions in number 7. Dave? Okay, so let's take a look at this chart. This describes the tuition at this particular college to Montgomery County residents. I'm just going to pick this row at random. So looking at that row right there, the first column says this person is taking 4 credit hours, and the rest of it is going to describe the charge for taking 4 credit hours. So you have your standard tuition, the $428, but as you well know, that is not the only charge that college students face. There's the facility fee, which is $20. There's a technology fee, also $20. Transportation fee is $16. Total $484. Okay? So what we're going to do is we're going to calculate, here we are, the ratio of total cost to number of credit hours. Total cost to number of credit hours. What's the most important word in the middle of that phrase? 2. That tells you what goes upstairs, what goes downstairs. So for this particular row, upstairs, we're supposed to put total cost. What is it? 484. Downstairs goes the number of credit hours, 4. So 484 to 4. And if you want to be fancy, you include units. That's dollars and credit hours. And we reduce, and this happens to go in evenly. What do we get? We get 121. Which if we want, we can put it over a 1. Which means for that row, and not necessarily for any other row, but for that row, it costs $121 per credit. For every 1 credit you take, it costs you $121. Okay, with your neighbors, decide on 2 other rows. They can be any rows at all. Do that same calculation, total cost to number of credit hours, and reduce. Look, so what did we get? 121. For any row that you guys picked, hopefully you got around to the same 121. So what does that mean? It means no matter how many credits you take at Montgomery College, you will be paying $121 per credit. Now, I can't say that that's exactly true here. I can tell you when I was in college, that wasn't true. When I was in college, there was a per credit rate if you were part-time, but if you were full-time, there was just, this is how much you pay. And so in a semester where I took 15 credits, I paid whatever I paid. In the next semester, I was crazy. I went to 17 credits, but I paid exactly the same thing. So in that case, because I'm paying the same amount for, on the one hand, 15 credits and the next hand, 17 credits, I don't remember a lot of that 17 credit semester, let me tell you, but it wasn't the same. We wouldn't have gotten the same number every time, right? And so there's this key word that we use up here that says, if the ratio is constant, if it's always the same, like 121, then we say the 2 things are proportional. So you could say here that how much you pay and the number of credits you take are proportional in this example. but they weren't in my experience. Okay, next page. So it's a little bit blurry. I'm hoping that you guys can read the stuff that we're going to need from this picture. This is a snapshot of like the label on a drug. There's a certain bottle that this was grabbed off of. So there's a lot of info here. There's very little that we're going to actually use, but let's see if we can find it. So the first question here says, according to the label, what's the total number of milliliters in this vial? Anybody find it? Yeah, there's a 50 and there's a 10, but which one is the number of milliliters here? It's the 10, yeah. So it's, again, hard to read, but up there at the top, I've highlighted in blue, there's 10 milliliters in this bottle. Fair enough. But then there's this other number which several people grabbed onto, this 50 milligrams over milliliters. I can highlight it there, 50 milligrams over milliliters. What is that? Well, I'm going to write that in a different way. I'm going to write it over here. 50 is really the same as 50 over 1 milligrams over milliliters. Okay, I can keep those units where they are. So what that means to us is that in this bottle, there are 50 milligrams of drug for every 1 milliliter of fluid. So the drug is some solid thing, but it's been dissolved. But grams measure a solid thing. Milliliters measure liquid. So they had basically water, and they took this drug, like imagine salt. You pour salt into water. The water will taste salty, but you're not going to see the salt, right? It'll dissolve inside. So that's what's going on here. For every 1 milliliter, that's a fluid, you will find 50 milligrams of this drug, even if you cannot see them. Anybody know the word? It starts with a C that represents this kind of drug number. It's concentration. It tells you how concentrated the drug is. If we had another bottle and it was 100 to 1, well, that would be more concentrated, right? It would be more powerful. So you might use less of it to get the same effect. Okay, so let's see if we can use this fact to figure out how many milligrams of the drug are in here. So you might be able to just figure this out without doing all the stuff we're going to do, but I just want to practice setting up proportions. So I'm going to write that same fraction again, 50 milligrams over 1 milliliter. And then I'm going to write another fraction, and I'm going to use the units to help me figure out what's supposed to go. So you better put the same milligrams on top, milliliters on the bottom. Okay. How many milliliters were in this bottle? It was the 10 that we found. So there's definitely 10 milliliters of fluid in this bottle. The number of milligrams of the drug, that's X. That's what the question's asking for. How many milligrams of this drug are in here? So let's call it X. And even though it's after the fact, I'm still going to write up here, let X equal the number of milligrams of drug in the bottle. And the whole idea with these proportions is that the 50 over 1 and the X over 10, they should be exactly the same. This 50 over 1 is true for every like little droplet of stuff in this bottle. So let's see if we can use that fact to solve for how much drug is there. Okay, a couple of different ways to solve this. But first, what is the name of this kind of equation? Starts with a P. That is a proportion. Fraction equals fraction. It's called a proportion. So there's two basic ways to solve a proportion, and this is written on the next page, but we can just do it here. Anybody have any ideas, like anything that comes to mind when you see fraction equals fraction? Dan? Cross is part of it. Cross multiply. Raise your hand if you've done cross multiply before. That looks like everybody, just about everybody. So let's cross multiply. It's really easy to go wrong here, actually. 50 times 10, I'm just going to write that. And then the other one is 1 times x. I'm going to write that. And a lot of people, when they cross multiply, they say, okay, I had fractions, I get fraction. 50 times 10 over 1 times x. Okay, now what do? I had an equation before. There's nothing I can do that's going to change that. This is not an equation. So this is not a valid way to go from the first thing. So it's not that you get a new fraction. Actually, the whole point of cross multiply is that you don't have any fractions. It's that you set the two diagonals equal to each other. So we multiply across on both sides and make them equal. And in this case, we're done. How much is x? 500. And again, because I wrote it up here, it's easy to know that that's in milligrams. So the whole bottle contains 500 milligrams of that drug, and we're done. Okay, I said there were two ways. The other way, I think that Sandy doesn't generally, raise your hand if you had Sandy for 105. It's like a bunch of us. So I don't know that Sandy uses cross multiply as her default. I think the phrase that she uses, anybody remember it? So, yeah, it starts multiply both sides by both denominators. I think that's the wording that she uses. So if that's more familiar to you, then by all means, multiply both sides by both denominators. I'm going to write that equation again. 50 over 1 equals x over 10. And I'm going to multiply both sides by both denominators. On the left-hand side, the denominator is 1. On the right-hand side, it's 10. So I'm going to multiply both sides by 1 times 10. Over here, 1 times 10. Both sides, both denominators. And the whole reason for doing that is that, for example, on the right-hand side, what happens? The 10s cancel. That's the point. And on the left-hand side, it's kind of silly, but what cancels? The 1s cancel. It wouldn't be silly if it were another number. And what do we get? 10 times 50 equals x times 1. Oh, look. That's what cross multiply gave us. 10 times 50 equals x times 1. Whichever way, whatever you're comfortable doing, you do. Okay, let's move on. We're going to skip number 9. If there's time, we'll come back. But let's move on to the next page, and we'll take a look at number 10. And in number 10, I'm going to ask you guys to solve these proportions by either doing cross multiply, if that's what you like, or multiplying both sides by both denominators. So see if you can work with your neighbors. If you don't know how to start, ask somebody nearby.